Is the world you see truly real? Have you ever thought about this? The red apple you see may appear to a dog as nothing more than a hazy patch of gray. The colorful underwater world in your eyes, in the eyes of an octopus, may look as rough as a faded old newspaper. So how exactly does the world seen by animals differ from that of humans? We will temporarily borrow the eyes of animals to personally experience that bizarre and fantastical world they see. A real world that may even overturn your worldview. Our first stop begins with the most familiar animal, the dog. There has long been a saying that a dog's world is black and white. But this claim is actually only half true. They are not completely colorblind. They are naturally red-green colorblind. Humans have 3 types of cone cells, allowing us to perceive red, green, and blue. This makes us the masters of color among mammals. Dogs, like most mammals, have only 2 types of cone cells, sensitive to blue and yellow. This means they cannot distinguish red from green. When you are standing on a green lawn, excitedly throwing a bright red toy ball to your dog, in the dog's eyes it may very well appear as a camouflaged, hard to distinguish grayish-yellow object. They are both mammals. So why is there such a difference? The answer traces back to the age of dinosaurs. The ancient ancestors of mammals were small creatures, living as nocturnal animals in the shadow of dinosaurs. In the long darkness of night, the ability to distinguish colors was far less important than seeing shapes clearly in the dark, so they gradually lost part of the cone cells responsible for color perception. Instead, they invested their abilities entirely into rod cells responsible for night vision. Although this turned their descendants into colorblind creatures, it also granted them far superior night vision and motion detection abilities. In other words, their eyes are practical tools designed for survival, rather than for appreciation. A similar story also happens with bulls in bullfighting arenas. When we are immersed in the intense atmosphere of a bullfight, we often think it is the red cape that enrages the bull. But the truth is, bulls, like dogs, are also red-green colorblind. In the bull's eyes, the red cloth in the matador's hand may be no different from a green or gray cloth. What truly provokes the bull is the constant waving motion and the noisy, oppressive atmosphere of the entire arena. That splash of red is merely a dramatic color added by humans to embellish this cruel performance, leaving the grayscale world of mammals behind. Let us shift our perspective to the sky. The name eagle itself has long been synonymous with sharp vision. As masters of the skies, just how terrifying is their eyesight? First of all, an eagle's visual resolution is 4 to 8 times that of humans. Even at an altitude of 2 miles, it can precisely lock onto a rabbit running on the ground. This is thanks to the extremely high density of photoreceptor cells in its retina, especially an area known as the fovea, where the cell density is more than 5 times that of humans. Even more astonishing is that eagles have 2 foveae, one for wide-angle scanning and another for ultra-high-precision telephoto targeting. This mechanism makes their eyes like a top-tier DSLR camera, able to instantly switch between wide-angle and telephoto lenses. But seeing clearly is not the eagle eye's greatest strength. It can also see through camouflage. Eagle eyes can perceive ultraviolet light invisible to humans. Many small mammals, such as voles, use urine to mark their territory and travel paths, and this urine reflects strong ultraviolet light under sunlight. What looks like a uniform grassland to us, in the eyes of an eagle, becomes a clearly marked highway map for voles. By following these glowing markings, it can easily capture its lunch. Simply put, eagle vision is a flawless system evolved for precise air-to-ground strikes from the sky. Now let us shrink ourselves and enter the world of insects. If you ever had the chance to closely observe a fly or a dragonfly's eyes, you would find that it is not a single eyeball, but a compound eye made up of tens of thousands of individual hexagonal small eyes stitched together. In fact, each of these tiny eyes is a complete miniature visual unit with its own cornea and photoreceptor cells, each responsible for capturing an extremely tiny pixel of the visual field. And then inside the brain, these tens of thousands of low-resolution images are stitched together into a unique mosaic image. This visual system sacrifices the high-definition image quality we pursue, but gains 2 unparalleled super abilities. First is an almost 360-degree ultra-wide field of view. The compound eyes nearly cover the fly's entire head, allowing it to monitor simultaneously threats coming from all directions, with almost no visual blind spots. Second is extremely high temporal resolution, what we commonly refer to as bullet time. Due to the phenomenon of visual persistence, the human eye can distinguish about 24 to 30 frames per second, which is why movies look smooth once the frame rate exceeds this threshold. But a fly's compound eyes can process more than 200 frames per second. Why can you never swat a fly? This is actually the reason. A fly swatter that appears lightning fast to us is in the fly's eyes a series of movements slowed to an extreme, so slow that the trajectory can be clearly predicted, making it easy to dodge. At its core, an insect's compound eye is essentially an extreme high-speed dynamic perception system, its primary function being to ensure that the host has 360-degree blind spot-free monitoring during high-speed flight to detect sudden dangers in time and react rapidly. If the world seen through the eyes of the previous animals were still barely understandable and imaginable to us, then the next superhero from the ocean, the mantis shrimp, will completely shatter all our understanding of what vision is. Humans have 3 types of cone cells, forming trichromatic vision, while the mantis shrimp possesses as many as 12. This means the mantis shrimp has 12-color vision, and can see 12 different colors. The 7-color rainbow we see may appear to it as dozens, or even hundreds of different colors, forming an unimaginably brilliant band of light. The colors we use to distinguish objects may appear crude to it, like an uncolored black and white photograph. But the story does not end here. In addition to these 12 color receptors, the mantis shrimp also has several extra photoreceptor cells, specifically used to perceive polarized light, a physical phenomenon that humans can hardly perceive directly. This type of light exists everywhere in nature. The reflection on water surfaces and light from the sky contain large amounts of polarized light information. The mantis shrimp can not only see polarized light, but can also distinguish whether it is linearly polarized or circularly polarized. This ability is unique across the entire animal kingdom. By using this polarized light vision, the mantis shrimp can easily see through many transparent or semi-transparent prey and predators. In its eyes, a transparent jellyfish may appear as a clearly outlined object, shimmering with eerie polarized light. The eyes of the mantis shrimp have already surpassed the limits of our understanding. What it sees is likely not a world made of objects and colors, but a world composed of complex spectral information and polarized light patterns, a dazzling stream of information. From the grayscale world of dogs to the GPS-like maps of eagles, from the bullet time of flies to the super spectrum of mantis shrimp, along this journey, we can clearly see a pattern that every kind of eye is a solution born for survival. The evolution of eyes has never had a single unified optimal solution, only customized solutions for specific problems. So let us return to the original question. What exactly is different between the world seen by animals and humans? The answer is, animals see a world specially tailored for themselves, a functional world that helps them survive to the greatest possible extent. And what we see is a world that can be understood, interpreted, and endowed with meaning. Compared with the supervision of animals, human eyes may be somewhat limited, but this is precisely our great starting point, because we cannot see the things we ought to see. We ignite the torch of exploration and invent microscopes and telescopes, infrared cameras and spectrometers to extend the boundaries of our senses. And this curiosity-driven, never-ending exploration may be what defines our species as possessing the most remarkable vision.